Kinetic energy is the energy associated with moving objects. If an object is stationary, it has no kinetic energy. The amount of kinetic energy increases as the velocity of an object increases. It decreases as the velocity decreases. The same rules for velocity apply as previously. A change in direction is a change in velocity, so changing direction, but maintaining speed requires a change in energy. Energy is still force multiplied by the displacement in the direction of the force, so W equals Fs. Energy equals force times displacement. If we replace force with Newton's second law, mass times acceleration, this gives us an equation for energy equal to mass times acceleration times displacement. If we assume that acceleration is constant, we can use the Suvat equations from our discussion on motion with constant acceleration. We can use the equation for final velocity as follows. Final velocity squared equals initial velocity squared plus twice acceleration times displacement. It is the acceleration times displacement aspect we are interested in, as we can insert this section straight into our equation from earlier. In short, we rearrange the equation from above, insert that equation into the first equation, and expand out the brackets, and this gives us energy of a moving object, the kinetic energy, in terms of mass, final velocity, and initial velocity. The equation is kinetic energy equals mass times final velocity squared divided by 2, subtract mass times initial velocity squared divided by 2. We can assume that the object always starts from rest, so our initial velocity has a value of 0, and the initial kinetic energy is also 0. This will give us our commonly familiar equation for kinetic energy of kinetic energy Ke equals half mass times velocity squared. As with gravitational energy, kinetic energy must be conserved. The final kinetic energy minus the initial kinetic energy must equal the change in kinetic energy, etc. It is when we talk about what this change in kinetic energy is converted to that a discussion of conservation of energy becomes more interesting.